Hi everyone. Today we're going to be looking at graphing the tangent function. So first I want to start with this warm-up. Let's evaluate the function, the tangent function for each of these values. So we'll start with tangent of pi thirds. I'm going to go ahead and draw out my coordinate plane. I know that pi thirds is in quadrant 1. So I'm going to go ahead and draw out my right triangle, drop that perpendicular. The reference angle in radians is pi thirds. So across from pi thirds, we have our root 3 over 2. And across from our pi sixths, we have 1/2. The tangent is equal to the ratio of y over x. So this must be equal to the square root of 3 over 2 over 1/2, which is equal to the square root of 3 over 2 divided by 1/2, or times 2 over 1, which is just the square root of 3. The tangent of pi, we'll go ahead and draw this. I know that pi radians is exactly on the negative x-axis, which has coordinates -1, 0. Tangent, again, is the ratio of y over x, so we have 0 over -1, which evaluates to just 0. 5 pi sixths, this is in quadrant 2, so we'll go ahead and drop our perpendicular to draw our triangle. Our reference angle in radians is pi sixths, so that means that our vertical component is 1/2, and our horizontal component, or x value on the unit circle, is -root 3 over 2. So we have positive 1/2 y over x over -root 3 over 2. So this is equal to 1/2 divided by -root 3 over 2, or multiplied by the reciprocal times 2 over root 3, negative. We get -1 over root 3, and rationalizing the denominator by multiplying by root 3 over root 3, we get -root 3 over 3. Okay. 5 pi fourths, we have in quadrant 3, drop that perpendicular. Our reference angle is pi fourths. This is our 45, 45, 90 triangle. Both the horizontal and vertical components are -root 2 over 2. Because they are exactly the same thing, the ratio of the two is just simply equal to 1. Okay, anything over itself is equal to 1. This is positive in quadrant 3. Tangent of 3 pi halves. So we have, that's another quadrantal that's on the negative y-axis. This point on the unit circle has coordinates 0, -1. We know that tangent is equal to the ratio of y over x, so we have -1 over 0, which is undefined. We cannot divide by 0. Okay. And number 6, we're going to do this without drawing a triangle. Find the tangent of 11 pi sixths. Well, I know that the reference angle here is pi sixths, though in fact this is very similar to number 3, where we also had a reference angle of pi sixths. But instead of quadrant 2, we're looking at quadrant 4. So if this is in quadrant 4, we have the same answer, -root 3 over 3. Just as a reminder, if I wanted to know the sign of sine, cosine, or tangent, whether they're positive or negative, I know that all three of those trig functions are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. One way that we remember this is all students take classes for the quadrants 1, 2, 3, and 4. If I know that we're in quadrant 4, with a reference angle of pi sixth, I know that tangent's going to be negative because it's not in quadrants 1 and 3. It's in 2 or 4. So we have a negative tangent, and our reference angle of pi sixth tells us it's the -root 3 over 3 as opposed to -root 3. Okay? All right. So let's go ahead and graph enough cycles of y is equal to the tangent of x to fill the grid using the knowledge of the unit circle. So I'm going to go ahead and do a table of values, and I'm just going to start choosing some of those values. I'm going to say 0, we're going to do pi fourths, we'll do pi halves, we'll do 3 pi fourths, we'll do pi, 5 pi fourths, and we'll go all the way up to 2 pi, counting up by pi fourths. So 3 pi halves, 7 pi fourths, and 2 pi. Okay, so plugging in 0, the tangent of 0. Remember on the unit circle, I'm just going to draw the coordinate plane with the unit circle. 0 degrees is on the positive x-axis. Y over x is going to be 1 over 0. I'm sorry, 0 over 1, because the coordinates here are 1, 0. So then the tangent is equal to 0. Okay? For pi fourths, remember that's our 45, 45, 90 triangle. Both the vertical and horizontal components are equal in magnitude. Okay, and in quadrant 1, they have the same sign as well. So they're both positive. So then our tangent must be root 2 over 2 over root 2 over 2, which is 1. Our first quadrantal, so pi halves, or I guess 0 is a quadrantal. So at pi halves, we have y over x. So our y value is 1. Our x value is 0. This is undefined at pi halves because we have this point here, so 0, 1. We have 1 divided by 0. At 3 pi fourths, this is again our 45, 45, 90 triangle. So we know it's going to be some 1 because we have that root 2 over 2 over root 2 over 2. But now that since we're in quadrant 2, we know that the tangent is negative here. At pi, we have, this has coordinates negative 1, 0. So y over x is 0 over negative 1. The tangent is equal to 0. 5 pi fourths is that 1 again, but it's going to be positive because we're in quadrant 3. You might be seeing a pattern now. 3 pi halves, we have that 0, negative 1. So then we have negative 1 over 0, which is undefined. We have 7 pi fourths, which is that 1. That's our special right triangle, 45, 45, 90. In quadrant 4, however, the tangent is negative. And finally, at 2 pi, this is equal to the tangent of 0. Okay, so let's go ahead and plot some of these points. We have pi fourths, 1. We have pi halves, undefined. We have 3 pi fourths, negative 1, pi, 0, and 5 pi fourths, 1. 3 pi halves is undefined. 7 pi fourths, we have negative 1. And then at 2 pi, we have 0. And in fact, this pattern continues also in the negative x direction. So I'm going to just continue this pattern. You can see that we have these groups of 3 points, but then separated by a break in the graph. Okay? So we have to consider what's going on near those breaks at pi halves and at 3 pi halves. Okay? Let's consider what's going on to the x's and y's. So as we move closer to pi halves, as the angle increases and we get really close to pi halves, our x values are getting smaller and smaller, and our y values are getting greater and greater. Okay? Our x values are getting smaller and smaller, and our y values are getting greater and greater. So therefore, the ratio of y over x, if x is getting really tiny, we're dividing by a smaller and smaller number. And our y values are getting greater and greater. So we have this greater number divided by a very small number. That's going to cause the ratio, that quantity, to continue to increase very quickly. It's going to approach a very large number. In fact, it's going to continue approaching infinity. Okay? At pi halves, it's undefined. So here on our graph, we see this represented as a vertical asymptote. So I'm going to draw this as a dotted line because it's not part of the function, but it affects the function. And then those y values continue off into infinity. So this function, I'm going to expect to go continuing to increase and get closer and closer to the asymptote. Let's consider what's going on as we move closer to pi halves from the left-hand side. Our x's are negative and our y's are positive, so the ratio is going to be negative. However, that quantity is, like that relationship is the same. We're dividing by a smaller and smaller negative, and our y values are growing. They're getting bigger and bigger. So this ratio here is going to approach infinity, but our x is negative. So it's actually going to be approaching negative infinity because we have a positive over a negative. So on the right-hand side of this graph, on the right-hand side of pi halves, we're going to be approaching negative infinity as we get closer and closer to that asymptote. And so we can see the shape here. The tangent is going to continue to grow and grow and grow on the left-hand side of that asymptote. And on the right-hand side of the asymptote, it's going to decrease and it's going to get smaller and smaller and smaller, or I guess lesser and lesser and lesser, approaching negative infinity. And in fact, this function is also periodic, so it continues to repeat itself for every pi units. So we have another vertical asymptote at 3 pi halves, and the function is going to continue approaching infinity on the left-hand side of that asymptote, but then approaching negative infinity on the right-hand side of that asymptote. Okay, and I'm going to go ahead and draw both ends there. In the negative side, remember negative pi halves is coterminal with 3 pi halves, so negative pi halves should have the same value as 3 pi halves for the tangent of x. And so we have another vertical asymptote at negative pi halves, at negative 3 pi halves. And so we've kind of got like this, it's not like sine or cosine where we have this wave shape, but we've got kind of like these repeated patterns here of like these long stretched out curves here. Okay, so this is the graph of the tangent function. It is periodic because it repeats over a given interval. And that interval, as you can see, is pi units in width. Okay, so each of these parts here are going to repeat for every pi units. So you might notice that the period of the tangent is pi units, whereas for sine and cosine, remember that's 2 pi units. Okay? All right, so let's summarize for 0 to 2 pi, the domain. So remember 0 to 2 pi is from here to here. The domain is going to be all real numbers except for where it's undefined, so pi halves and 3 pi halves. So we're going to write this using interval notation. We have 0 to pi halves, not including, and then from pi halves to 3 pi halves, again, not including, and then we have from 3 pi halves to 2 pi, and we do want to include 2 pi. The range, let's see what y values does this hit. Well, this continues up to infinity, and continues down to negative infinity. The range is all real numbers. So negative infinity to infinity. State the local extrema. So remember that these are your local maxes and mins. Well, because this doesn't change from increasing to decreasing or decreasing to increasing, there are no local maxes or mins. So this is none. There are no local extrema. What interval is the graph increasing? So remember, we're looking from 0 to 2 pi. So this function is increasing from 0 to pi halves, from just after pi halves to 3 pi halves, and not including, and then just after 3 pi halves to 2 pi. Okay, so this is just like the domain. We're going to be increasing from 0 to pi halves. We don't want to include pi halves. We have from pi halves to 3 pi halves, and we don't want to include that. And then we have from 3 pi halves, not included, to 2 pi. Okay? For what interval is the graph decreasing? Well, this function always increases over that interval. In fact, over all the domain of this function, it's always increasing. There are no intervals for which this function is decreasing. So this is not decreasing at all. You can say none. You can say the null set, which is like a 0 with a slash through it. Okay. Graph each function using the parent function. So here's our table of values. We'll graph tangent of x, and then applying the transformations. So I'm going to just write one. I'm just going to write one period for the tangent, which remember we know is pi units in width. Now remember, this is centered, just a characteristic of the tangent graph. It's centered around about the origin. So on the left-hand side of this first cycle here, we're going from negative pi halves to pi halves. And often this is what we'll cite as the domain of the tangent, especially for when we're restricting the domain for finding an inverse, which we'll talk about later. But this is the tangent graph is centered around 0, 0, and it's from negative pi halves to pi halves for one cycle. Okay, so I'm going to go ahead and just evaluate. We have negative pi halves, negative pi fourths, 0, pi fourths, and pi halves. Okay, so remember the tangent function, the parent function, is undefined at negative pi halves and at pi halves. At negative pi fourths, the tangent of x is negative 1. We have the origin 0, 0, and we have pi fourths 1. All right? So now for the transform function, we're not doing anything with the input. We're just simply taking the tangent of x. So I'm going to choose the same x values. So we have negative pi halves, we have negative pi fourths, 0, pi fourths, and pi halves. Okay, but our outputs, our f of x values, we're going to multiply them by 3, and then we're going to add 1. So where it's undefined, it's still undefined. We can't operate on a value that's undefined. So we still have asymptotes at negative pi halves and pi halves, but for at negative pi fourths, we're going to multiply negative 1 times 3 and then add 1. So negative 1 times 3 is negative 3, and then adding 1 is negative 2. At 0, 0, we're again multiplying by 3 and adding 1. 0 times 3 is 0, plus 1 is 1. And finally, at 1, we're multiplying by 3 is 3, add 1 is 4. So let's go ahead and sketch this graph here. We're going to draw in the first cycle, and then we know it's periodic, so we're going to just repeat that motion to fill the grid. Okay, so we have asymptotes at negative pi halves and pi halves. We have negative pi fourths, negative 2. We have 0, 1. This is our y-intercept. And then we have pi fourths, 4. Okay, so we have this function here. And it's a really stretched out tangent graph. And try to get real close to those asymptotes. It continues on and on and on. Okay, let's go ahead and repeat this motion. So I know that at 3 pi halves, we have another asymptote. And at negative 3 pi halves, we have another asymptote. We'll start with the right-hand side. Just next to that asymptote, we have negative 2. At pi, we have 1. And at 5 pi fourths, we have 4. And so this approaches infinity and negative infinity. Okay. And we've got room for a couple more points here on the end. So we have this little piece right here. And I'll go ahead and extend this to indicate that it's also increasing over here. And we'll continue the graph over here. So we have our 4, we have our 1, and we have our negative 2. Okay. And then we'll do that for that last piece as well. We have our 4 and our 1. Okay. So a couple things that I want to note about this. Notice that this is a vertical stretch by a factor of 3 and a vertical shift up 1. So you might notice that all those middle values are all shifted up 1. So they're all along the line y equals 1. Likewise, if we think of for sine and cosine, this is our amplitude. This is also going to be that vertical spacing between our middle point and our left and right points. So at pi fourths and negative pi fourths in this example. So that's going to stretch this vertically. So instead of a distance of 1 between these points, we have a distance of 3. Okay, let's try number 2. G of x is equal to negative tangent of 2x. So again, we'll start with the parent function, negative pi halves. We have pi fourths, 0, negative pi fourths, 0, pi fourths, and pi halves. We have the values undefined. We have negative 1, 0, 1, and undefined. Okay. So the transform function, we have a reflection over the x-axis, and we have a horizontal compression by a factor of 1/2. So the way that we see this in the graph, we'll start with that b value. So again, this is still going to be represented as the b value. The only thing that's going to change here is, if you remember for sine and cosine, we had the period is equal to 2 pi over b. And the reason why we have that is because it takes 2 pi radians to do one full rotation around the circle. Or the period of sine and cosine is 2 pi radians. Now we just learned that the period of the tangent, however, is pi radians. So to find the period for tangent, instead of doing 2 pi over b, we're going to do pi over b, because pi is the period for the parent function. Okay, so if our b value is 2, then our period must be pi over 2, or pi halves. Okay, now remember, this is centered around the origin, so that tells me that all of my x values are going to be divided by 2. So our negative pi halves is going to be negative pi fourths. My negative pi fourths is going to become negative pi eighths. My 0 stays 0. My pi fourths becomes pi eighths, and my pi halves becomes pi fourths. We're dividing all of these inputs by 2. Okay? We can also double check that if we're going from negative pi fourths to positive pi fourths, the width of that interval is pi halves units. We've got a quarter pi on each side. So on each side, if we add those together, that's going to be a total of pi halves on each side of the y-axis, right? Other than that, the only thing that changes to the output is that it flips the sign. So now we're going to go undefined 1, 0, -1, undefined. So all of our y values, all of our function outputs are going to flip in sign. Okay, so let's go ahead and graph this. So at negative pi fourths, undefined, that's a vertical asymptote. At negative pi eighths, that's going to be exactly halfway in between negative pi fourths and 0. We have a value of 1. We have the origin 0, 0. We have pi eighths, -1, and then we have our vertical asymptote at pi fourths. So you can see one cycle here. You can see that it's compressed horizontally by a factor of 2. We've squeezed that tangent function together. And then we've also got that reflection over the y-axis. It's now oriented, over the x-axis. It's now oriented differently. It's flipped over the x-axis. Okay, so let's go ahead and repeat this pattern. We've got asymptotes every 2 increments on this graph here. So we've got a lot to draw here. We'll fill in that grid, draw in all the cycles that you can. We want to see that repeated motion over the whole domain. All right, so here's all my vertical asymptotes. All of our middle values are going to be on the x-axis because we didn't shift this up vertically at all. And then those other 2 values, remember, are going to be a distance, a vertical distance 1 from those middle values, but it's going to be a horizontal distance of pi eighths, and it's going to be decreasing from left to right. Okay, so we've got these values here. If you're having trouble graphing these on your own, you can pause and graph along with me, and then you can fill in your grid. Okay, so we've got this shape here. Let's go ahead and connect our dots and draw in our graphs. I like to graph these by starting in the center, and that way I can kind of get the curvature of the tangent. It kind of reminds me of the cubic function in the way that it curves a little bit. It's not quite exactly the same, but it kind of reminds me of it, the graph anyway. Try to get real close to those asymptotes, but try not to cross them. These are vertical asymptotes, and the function is undefined, so be sure not to cross those asymptotes. If you cross those asymptotes, that would be indicating that the function exists at those x values, which is not true. All right, and also at the ends, go ahead and extend those graphs. So at both ends and draw those arrowheads. All right, so we've got a lot of those repeated motion. Okay, we've got one more for us today. We have 2 tangent of 1/2 x. So if I'm looking at the transformations here, this is a vertical stretch by a factor of 2, and we have a horizontal stretch by a factor of 2. We'll start with the parent function. Remember, that goes from negative pi halves to pi halves. The period is pi. So we have negative pi halves, negative pi fourths, 0, pi fourths, pi halves. Our y values are undefined, -1, 0, 1, and undefined. Okay, so all of our x values, this is a horizontal stretch by a factor of 2. All of our x values are going to be doubled. So negative pi halves becomes negative pi. Negative pi fourths becomes negative pi halves. 0 stays 0. Pi fourths is pi halves. And then pi halves becomes pi. So we're going from negative pi to pi. So you might be able to tell already that our period is going to be equal to pi over 1/2, or pi divided by 1/2, which is 2 pi. And we can double check that from our table of values here. We have from negative pi to pi has width 2 pi units. Okay, 2 pi radians. So then our h of x values are all going to be doubled. So we have undefined, -2, 0, 2, and undefined. Okay, so we have vertical asymptotes at negative pi and pi. So we've got a really wide graph. This is that horizontal stretch. At negative pi halves, we have negative 2. We have our origin, 0, 0, and pi halves, 2. Okay, I'm going to go ahead and sketch this graph here. Remember, it's kind of curved. Try not to have straight lines. It is curved. And then let's go ahead and draw that repeated motion again. So I know that we have 2 pi, 0. And then we have 3 pi halves, negative 2. So go ahead and draw the rest of that. We have negative 2 pi, 0, and negative 3 pi halves, positive 2. And that goes up to infinity. Okay, so we can see the shape here. Again, that vertical distance between that middle point and those side points are a distance of 2. That's that stretch. And then we've got that horizontal distance as well is a distance of 2 because that's that stretch as well. Okay. Our period is then also stretched from negative pi halves to pi halves to negative pi to positive pi, a width of 2 pi. All right. All right, so this has been graphing tangent. We're going to get a whole lot of practice on this, so we'll see you tomorrow in class. Have a great day, everybody. Goodbye.